Wow. Hello. Hello, a rare Eudemon stream. Yeah, I have been not doing any streaming lately. So I just started I started applying for jobs last week. And I have been doing coding challenges off stream, but I guess it's a better practice for me if I actually try to talk to viewers. I mean, not talk to viewers, but like explain what I'm doing like this, and not just being silent. So I'm gonna try that. We're gonna dive straight into the question. And today's question, we are doing in place reversal of a linked list. Also, hello Cassie. And as you see, I've been doing other questions as well, but oh my god, there's so many patterns. Okay, so challenge 1, reversal of alternative k element sublists. Given the head of a linked list and a number k, reverse every alternating k size sublist starting from the head. If in the end you are left with a sublist that has less than k elements, reverse it too. Hi Sky. So the question here is we need to reverse k. In this case, k is 2. So for every 2 elements, we need to reverse those 2 elements. And then the next 2 elements, we're gonna stay the same. And then next 2 elements, we're gonna reverse them. And if in this case, it's an even number. But if it's an odd number, so the last element will be just left with one linked list. So we also reverse that as well. Hello KY, hello Simon. Yeah, it's long time no see. Hello guys. So what we're doing here is say 1, 2, 3, 4, 5, 6, 7. Since we are doing reversal, it'll be easy if we can like just create a new thing and loop them multiple times, but that would be a kind of brute force, which has a high time complexity. So what we are doing is in place reversal. So in place we will need a. So we're going to set the current element as the previous element, and we're also gonna set the next element as the current. The reason why we need 2 pointers is since we're gonna reverse, like for example, this will be pointing to this, but what we want is have this point to this, which means if we do that, so if we do 2 point to 1 instead, that means 2 node 1 point to 3. This will be breakout. So that means we will lose access to the next element. So every time when we move forward, we're just gonna move previous and current forward. So there's a there's a pointer pointing to the next element, which is already cut off from this list. This is why we need two pointers. One is the last element that we reverse the list, and the next one is what we're gonna work on next. So since we are doing alternative, so we can have a k counter whenever so we reverse this, and then we have 1.23. So that means we need to have a something like, we need to have a pointer as well. I mean, not a pointer, like we need to remember the element of this, because after we done the reversal, we're gonna have it point to the next current. So we need a last, previous, and last current with this. Do we need a last current? Also, we do need a last current because the head is gonna change. So this is the last previous, which is equal to 1. And then last current will be 2. Do we need 2 though? Last current 2. Because we need to update the heads. We need to update heads. So after this reversal, the new head is 2 instead of 1. So head will just point to... we can have head point to this last current. So this is the basic. Since we only reversaling every alternative k, we can have a boolean. So right, reverse boolean. If it's true, then we do reverse. If it's false, then we move k elements. So that's the basic idea of the algorithm. So let's code that. First thing we need to do is we need to have a previous and current. So we're gonna set previous to be the current heads and current to be head dot next. Actually, should we do that or just no? Current is head. And then while true, we're gonna move forwards. We're going to set the last previous is equal to previous, and then last earned is equal to current. Right, so and we also need a k. Not k, let I equal to 0. So while current is not null, as the last element here is null, we're gonna break out if we hit the last element. And we want to loop only k times. So while and I less than k. Right, so heavy and okay, we also need reverse reverse is true, and reverse and reverse. So if reverse is true, we need to have a next to hold the next is equal to current bond next, and then we just need to have instead of 1 to 2, we want to 2 to 1. So previous is 1, current is 2, and we want to move current to 3. So next is equal to current on next, and then we want 2 to point to 1. So current on next is equal to previous, and we want to update previous to the current, and current will become the next. And after that, we're gonna do I++, because we only want to iterate k times. In this case, I think reverse might be able to. This is the case if we want to reverse the sub list. Is this your homework? No, this is just a. It's not homework, it's just a Leetcode style practicing for job interviews. So this is the case if we want to reverse it. And let's write a case if we don't want to reverse it. So if reverse, then we do this. Else, if it's not reversed, then we just move to the next while I is less than k. So in this case, we also in this case, we just set previous to current, and then current is equal to current.next, and then I++. All we're doing here is move forward without reversing it. Okay, so after the reverse is done, since we have been updating the index of current, so let's check if current is null, then we break out. And then for the first reversal, remember for the first reversal, we need to update heads. Oh, I think this shouldn't be next. If we set this to GNOME and set the current to be head. So if last previous is no, then we want to update the head. We want to update head to be last current. Wait, not last current. After we move, we want to update. After we move, the last element, the head is 2. In this case, head is 2. So head is the current previous. So head is the current previous. Otherwise, as previous. After this is done, we want the last previous to point to current. So likewise, last. Wait, regardless doing this, we need to update this. So last previous dot next should be pointed to current here. And then this, we ignore this part. And then, so this will still point to here. But for this one, we need to reverse this. So now, after the reversal, 4 is point to 6, 6 point to 5, 5 point to 7. And previous is 6. Current is 7. After this, and the last previous, this is last previous and this last current. So after that, we want the last previous to point to current previous. So otherwise, last previous is equal to current previous. And last previous dot next. Wait, no. Last previous dot next is equal to last previous point to the current previous. Otherwise, last previous equal to current previous. Previous dot next. Wait, hold on. Why is this different? We want 1.23. In this case, 4.26. 6 is previous. last current point to the current current. Last current down next. Last previous down next. Wait, this doesn't make sense. Previous. This is last previous. This current previous. And we want the last previous to point to current previous. Last current to point to current current. And then we return head because we are updating head to the purpose. I think that's it, but this is probably wrong. Okay, let's walk this through 1, 2, 3, 4, 5, 6, 7. Initial previous is no. Initial previous, initial current is this. So after we're done with the K elements, the current previous is here, current is here. And because it's no, we want to update the head to be this is a special case when we first started the array. So we want to update head to be here. And then we want the last current. We want to update the last current. Thus this would be like this. And this will point to this. So I want to update the last current. Dot next is equal to current current. So last current dot next is equal to current current. That's correct. And then we move on next. Since we are not touching these two elements, these two will be skipped. So we update previous to be here and current is now here. So this is the last previous, last current. And then we go to the next one. Next two will be 5, 6. We reverse 5, 6. And then by the time at the end of reversal, the previous is 6. The current is 7. So after this is done, we want the previous to point to 6. And then this current to point to this current. So we want the last previous to point to the current previous. So last previous dot next is current previous. And the current last current dot next should be pointing to the current current, which is this. So well, the logic looks correct to me. I don't know why. I don't know why it's not working. What if I break at the end? I don't think that matters. Oh, yeah, that actually matters. Oh, yeah, okay, remember now. So reverse is true after we're done with this. If reverse... So we need to reverse the reverse. So reverse is equal to not reverse. So every time we loop k elements, we're gonna reverse the reverse. So run this. I is 0, I less than k. K is 2. So I is 0, run once, I is 1, run once. And then I is 2. So that's correct. Previous is equal to current. And current is equal to... Oh, this is wrong. Let's max equal to burn.max. Because I'm updating previous equal to current. Current to current next. Wait, this is right. Right, so previous is now this. And this is gonna be this dot next. Yeah, this is right. So why is it not working? 2 and 4, 6 and 8. So I always yoinking this number. At least in this case I yoink the first number, and the second one after the reverse is done, I yoink the first number. At least we know it's reversing. But we need to figure out why this number gets yoinked. Previous is current. Current is equal to current dot next. Next is equal to current dot next. Current dot next is equal to previous. And previous is now updated to current. Current is updated to next. Because this part is where we just want to reverse the pointer. And this is the special case. If we started since the beginning, we need to update the head. And otherwise, we just update the... We relinked these current. If it's no, then we break it out. Yeah, this looks correct to me. I don't know why it's not working. Next. The problem follows in place reversal of linked list pattern and is quite similar to the reverse AVK elements. The only difference is we have to skip K out alternative elements, so we can follow a similar approach and each In each iterations after reversing k elements, we will skip the next k elements. Hello, Crystal. Hello, you. I forgot to say hello. I responded to your message, but yeah, hello. So they have current is head. This is while current is not no. Okay. So they have the last previous is equal to previous. Last no of sublist is equal to current. Basically last current is current. Next. Okay, this doesn't matter because I put the next in here. So let I equal 0. So they have next equal to current next is equal to previous is equal to current is equal to next. That's correct. So if the last previous is not null, this case is if it's not in the beginning, then last previous dot next is equal to previous. I have that. Otherwise we just update the head to be previous. I got that. And if the last no don't next, well, this basically last current don't next is equal to current. I have that. Oh, what they did is instead of doing that, they just skip next one, and then you loop again. Okay. So instead of using a boolean to check whether you need to reverse or not, they basically within the same while loop you do the reversal and then you do the skip, and then you continue do the reversal and you do the skip. So that's just shorthanded, but the logic seems to be the same as the one I have. So I don't know why mine just skips stuff. So let's see. If I write it that way, so while current is not null, right, instead of reverse, so we're gonna cut out this reverse part. Cut out the else part. So this is where we just skip everything. If we skip everything, just put it here. And because I has been updated because the previous I, we need to update the I again. So this will okay. Run again. Reverse is not defined. Yeah, because I removed the reverse. Here. One again. Accepted! Submit. Cannot read property or no reading next. Oh, because this is using next. So while earn is not no and I less than pay, submit. Accepted! Wait, what was wrong with my logic earlier? While current is not null, last previous, last current. If current is not null, we loop k times. So this reverse the linked list. And then if we start it in the the first time we started, we want to update the head to the previous. Otherwise, the previous dot next is equal to next previous. Previous dot next, because this is the first special case, and this is the second case. So previous dot next, we want for to point to this previous, and we want the previous current to point to the new current. So this last previous dot next is previous, last current dot next is current, and this is and this part is this where we don't do anything. So we just update previous, we move previous to this here, and then we move previous again until we move them k times. So this is this part. So okay, I don't know why this time is working, but my logic hasn't changed. Anyways, next. Given the head of singly linked list and the number k, rotate the linked list to the right by k nodes. Rotate the linked list to the right by k nodes. K is 3, so we move this to the next. So move 1 by 4, 5, 6, and then have this move over the next k nodes. This k equal to 3. If k is equal to 8, 3, 4, 5, 1, 2, no. I don't get this. If k is 8, that means we... Oh, okay. K is 8. So this is 5, right? And then we reverse again. I should know if we count this as 6. So the next 2 will be here. So we move 2 to next k. This is 4. And then 4 again. I don't even understand this question. I don't understand the question, so I cannot do it. Next, introduction to stacks. A stack is a linear data structure that follows the last in. first out principle. This means that the last element added to the stack is the first one to be removed. Last in, first out. So push and pop. Understanding stack with a real life analogy. Imagine stacking book on a table. When you add a new book, you place on top of the stack. When you remove a book, you take the topmost book first, and the last book you add is the first one you take out. Okay. The last in, first out principle. Stack operates based on the first in, last out principle, which means the most recent added item is removed first. The first item added remains at the bottom until everything above is removed. For example, consider a stack containing a number. Push and pop, basically. This predictable behavior makes stack efficient to handling ordered data. Basic stack operations. A stack provides 4 fundamental operations. Push, add an element to the top of the stack. Pop, remove the topmost. Peek, return the topmost without removing. Oh, I don't know if there's a peek. JS, peek. Is there a peek? Peek. Array.peek is the one. Let's now looking at the stack. Peek returns the topmost element without removing it. Just stack peek is look at the first element. Oh, so peek back. Wait, is that a real JavaScript thing? I never seen a peek before. Since 2022, you can do stack adds -1. Oh, this is just make a class. Wait, hold on. I don't need to do all this fancy stuff. Cause we know the length of the stack if we're looking at an array. So peek would just return the last one. So return the index at array.length -1. That's all it does. Empty is just checking the array is empty. Full, actually I don't know about full. In this case, assuming that like they want us to make an object which has a limit, like restrictions on the object. Implementing stack data structure. Stack offers the push operations. The push step for push. Check if it's full. If not full, increment the top index. Insert a new element at the top index. The new element becomes a topmost. If we are just operating an array, we don't really need to increment the index. Pop, removing top. Check if stack is empty, retrieve the topmost. Remove tile by decrementing top index. Oh, do I really need to make that? If I need to implement this, that means we are not using an array, we turn it into a class. Peak. Return the top. Peak, return 40, stack remain unchanged. Is empty operation, check if the stack is empty. If the stack has no element, returns true. Otherwise, return false. Yeah, they're making a solution. Constructor capacity. Push pop. Peak is return top. Okay. Implementing stack using a linked list. This is much easier than using a linked list. Well, technically linked list. Yeah, I still think array is easier. Take away array-based stack are simple but have fixed size. Linked lists provide dynamic memories that require extra space for pointer. Oh, do I need to remember both? Okay, let's see. If you are doing it in a linked list, you have a top. Extra pointer basically topped. Oh, cause no, what the hell? Hold on. So this has a constructor and you inputting capacity, right? This is not really true if you are just using the like JavaScript array based, because you can just not input the capacity. So why would you not have capacity in the constructor if you're just doing linked list? Because you can also not have this in the array solution. Anyways, just complain. New node. So you're making a node. The node is just constructor this value, this next, this dot next. Push, you make a new node, and then new node dot next is this dot top. This dot top is the new node. New node dot next is this dot top. You make a new node. You have the new node to point to this dot top. And then you update this dot top to the new node. Why? So 1, 2, 3, 4, 5. Wait, hold on. Let's not make it too complicated. So currently that they have this. You make a new node. You make a new node is 4. And the new node dot next is this dot top. But there's no new node dot next. Because if you create a new node and just passing a value, next is no. So this dot top is become no. Right? And then you update this dot top. Oh, the next is Oh, okay. So top is here. You push a new node here. So the new node next is gonna point to this. So this is a linked list by just it's just in this order. So this points to this, and then you update the top, and then you update the top to be this. Okay. If you pop, then hello blue. Pop value is this dot top dot value, and you update this dot top. So if you pop this, you return this dot top, which is this. And then you update this dot top to be here. And this is just for Eudemon. Peep just returns this dot top, okay? Most modern programming language provides building stack implementations or support stack through existing data structures like list and array. Using building implementation is recommended because they are optimized, easy to use, and well tested. But meant for array. Yeah. So instead of all that operations, like I was saying, just use a fucking array. It's a method array. Now let's see how to use this. Freaking AI stuff. Stack implementation using building data structure. So you push, pop. Peak is just length -1. That's what I said. If it's empty, it's just length is equal to 0. Yeah. Next. Stacks are widely used in computer science and real-world applications due to their last-in, first-out behavior. They provide efficient solutions for problems involving reversibilities, function calls, and data backtrackings. Below are some key applications of stacks. Memory management. Manages function call in programming by pushing function calls onto the stack and popping them after execution. Oh, okay. Enable recursion where each function call gets a new stack frame. Help in checking local variables and return. Well, this is like basic computer engineering. So imagine you have a stack. You have a program that that has a function, right? The function does something, blah blah blah. Within that function, you may also call a different function, which also does blah 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 blah, and then return some value back to here, so your function can continue to operate. So in this case, you'll be like the first function A, is gonna put into the stack. You have 8 here, and then the program is gonna look through the function call here, and then they see a function C that puts C into the stack. So blah blah blah, and then blah blah blah. Expression evaluation and syntax parsing ensure correct extension. Oh, okay. Syntax parsing. So remember, like syntax parsing, you have an if statement. You open a brackets, and you need to close the brackets. Right. So you have a stack. There's a bracket that opened. And then within the bracket, let's say you have a while loop that opens a second bracket. And you need to close this bracket. So second bracket is here. You cannot close the first if unless you close the first. So the first corresponding bracket is a pop operation. So it takes out this first. And then the second bracket takes out this if statement, takes out this bar. So this is what it does. Expression variation, syntax parsing, ensure correct execution order in the arithmetic. I don't know how to pronounce. Arithmetic expressions by managing operators procedures. Precedence. Using parsing programming language, particularly in validating brackets and expressions, converting fixed expressions to postfix notations, which is easier for computer to evaluate. Undo redo mechanisms. Oh. So the Z, Control Z, basically in computer Z, Control Z. Control Z will remove the last operation, and then you Control Z again, remove the next operation. Stores user actions as stack operations in text editors, image editors, and IDE. Pressing undo pop the last action from the stack and reverse it. Redo reapplies the action by pushing it back to the stack. Backtracking algorithms using problems that require trying different possibilities and reverting if needed. Common in Sudoku solvers, maze, pathfindings, and queens questions. So stores previous state, allowing the algorithm to reverse to earlier position when a dead end is reached. Okay, backtracking stores the previous day. So in this case, say I have a link tree that does some actions. So you have A, B, C, D, E. So this is your goal. If you do A, B, so you A, B, C. Let's say this is not, but you have to perform some actions to get here. And you want to reverse that, so you pop C back, you pop B back, and you pop A back. I'm guessing that's what the backtracking algorithm does. The first search, yeah, basically what I just said. The first search explores a grab deep into one path before backtracking, using a stack to store nodes that needed to be revisited. Oh. Help in finding connecting components, cycle detections, and solving maze problems. Web page history and back button. So this is the same as the redo stuff. Every visit web page is pushed into the history stack. Clicking back pops the last visit page, returning the user to the previous one. This method allows user to navigate web page in reverse order efficiently. Stacks are simple yet powerful data structures with diverse applications in memory management. I need some water. And algorithm optimizations. Problem solving. The efficiency in handling reversibilities and sequential access to make them essential in both software development and real-world computing system. Next. Okay, problem number 1, balance parentheses. Given a string S containing blah 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 characters, determine if a given string of parentheses is balanced. A string of parentheses is considered balanced if every opening parenthesis has corresponding closing parentheses in correct order. Input is ba 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 is true because every this has a reverse this. What language are we using? I'm using JavaScript. Because I do mostly web application developments. I know a few languages, but like since if you go into interview, like your whatever thing that they provide you is limited to certain languages, and JavaScript just happened to be the most popular. It's the most popular and most widely known web applications language. So I think it's easier to use if you do that in a coding interview. Anyways, this is false because you have an opening here, but you don't have a closing for this. Okay. And well, it looks simple. I just need to map this with this. But how do I map them? Wait, hold on. This is the easy question. Why am I struggling? Push and pop. So these are all push operations and these are pop operations. And I had to map them too. This sounds very wrong, but First, I'm gonna convert s is equal to s dot splits, and we're just gonna turn into array. So while I let I is equal to 0, I less than s dot length, I pass this if si while for let I if si that sounds very wrong. So we make a new stack. Let stack is equal to new array. If I is equal to this, if it's equal to this, then we push if it's equal to this, or if it's equal to this, or if it's equal to this, then we push stack dot push si. Else, if si is equal to the closing bits, then we do stack dot pop. Let's make a 10 value. 10 is equal to nothing. So 10 is equal to stack dot pop. And if 10, actually no, don't need stack. I don't need a 10. I don't need a 10. So stack dot pop will just return. Hello. If stack dot pop is not equal to this value, so if si is equal to this, and if I pop that is not equal to this, then we return false. Otherwise we return true. So I just need to do that for every single symbol here. This is what I mean when I say it sounds wrong. It sounds wrong. And pop has to be this. And if the current reverse. And pop has to be equal to this. And if the current is closing, then the pop has to be next closing. So return, accepted, submit, wrong. Okay, because you only have one. So we don't need temp here. And if this push and this is the end. So if stack dot length, then we return false. So which means we meant to went through the whole stack and there's still some stuff left. Then we just return false. Submit. Accept it. How's my streaming going so far? I don't know. Yeah. How's it going so far? This sounds wrong. Cause like this is like manual mapping. Next. Okay. Yeah, they're doing the same thing. Manual mapping. So in this case, like they check whether the length is, if you have an opening, if you have a closing parenthesis, and there's no close and it's already empty, that means you cannot close that. They did a check here. However, in my case, I don't think we need a check because if we pop that and it's empty, the pop is gonna return undefined. So it's gonna be if you see a closing and the top is equal to undefined, so it's gonna return false anyway. So sounds wrong, but oh, no stacking. Okay, this is a shorthand. Gonna copy that. So instead of doing the length, we just do stack stop length. If there's something in there, that's false. Commit. Yeah, so they do if this. Next. How many hours is my stream? My streams are very random, so I cannot say how many hours. But I'm gonna end the stream here because it's been more than an hour now. But I'll be doing a lot of streaming. I mean, I'll be doing a lot of coding challenges, so I will start the stream again later. So see you guys next. Bye bye. 我不想一辈子被人踩在脚下。你以为我是臭氧放的？我等了3年，就想等一个机会。我要争一口气，不是要证明我了不起，我是要告诉人家，我失去的东西我一定要拿回来。